The OpenFlexure Microscope is an open-source 3D printed microscope. It is built around a Raspberry Pi and a few other cheap and easily obtained components. Using common tools, the microscope can be put together in a matter of hours. Richard Bowman, the leader of the OpenFlexure project at Bath University, explains the evolution of the microscope's design.
So it all started with a very simple version 1, where you squeeze it and the top moves up and down. And got steadily more complicated until we ended up at this, which actually moves really quite nicely in 2 dimensions on this stage here, and then focuses with this mechanism here.
One of the main uses of the microscope is for scientific research. A lot of biological and medical research requires the use of a microscope. The majority of these have used the same design for hundreds of years. They are controlled by hand, and observations are made through an eyepiece. Many research labs use automated microscopes such as this one, but they tend to be large and expensive. In contrast, the OpenFlexure microscope is small, meaning that an automated microscope can fit on any lab desk. This opens up the possibilities of automated microscopy to many more users. They are able to control the position of their sample with the built-in computer, view images on a screen, and save them for later analysis. Another use of the OpenFlexure microscope is for education. From schools to universities, microscopes provide a great opportunity for students to observe things that they have never seen before. The OpenFlexure microscope opens up these opportunities to even more students. As well as a practical tool for physics and biology study, the modularity and open source codebase of the OpenFlexure microscope means students and teachers can adapt and improve the microscope. The OpenFlexure microscope is powered by a Raspberry Pi and can be connected to the internet, which means the microscope can be controlled remotely in places such as here in Tanzania. As 3D printing technologies become more widely available all over the world, we are working with our partners at StickLab to ensure that the OpenFlexure microscope can be manufactured locally in Tanzania. This will support our aim with our colleagues at the Ifakara Health Institute that the OpenFlexure microscope can be used for automated malaria detection.